So sorry for the change in classroom. In the calendar of room booking it was showing L13 free, so I blocked it. Now I came to know they're taking a regular class there, but it's not blocked in the timetable. Anyways, so where were we? So what we have seen is in the first lecture we saw even spaces, Venn diagram, axioms of probability and spaces with equally likely outcome. And then the next lecture we saw conditional probability and Bayes theorem. Independence, although we didn't go through, but that day when we came for that recording, you guys were there, so you know what independence is. In case those who were not there, independence actually comes from that it's the product rule. And if it is mutually, this is what we wrote, it's written in the notes and we went over that day also. That day also, and if it's mutually exclusive, then this will be 0. And how did we reach this formula? We said PA P is equal to PAB over P of B. This was conditional probability, and if it is A is independent of B, then this will equal to A, and then you multiply with this and you get this formula. Right? That is how we reached conditional probability. We had motivated why this came. So the motivation is important for every formula I give. And then if it is mutually exclusive, then PAB is 0, which means that either PA will be 0 or PB will be 0. So mutually exclusive and independence can occur together also, but that is the idea. So that was the summary, but this is not working. So what we'll start today, we'll do two things: random variables and distributions. And I want to finish the 2 lectures of this week, which is Tuesday, Wednesday, today itself. So if it doesn't bother you, then we meet again at 4:45 after your lab and finish by 5:30 and not take a long lecture. Is that okay? So then the rest of the week you'll free, no? Tuesday you'll free, Wednesday you have a free slot. And I'll not bombard you with 2 lectures. And then we'll be normal schedule next week. Otherwise I have to go and recover next week, which will be a week before your exam, so you will stress out. So we'll see. Let's see how much I finish today. So we'll start with random variables. So what do you know about random variables? Besides the fact the English meaning of random and a variable, what else do you know? Are you hearing it for the first time, random variables? The way we want to study in this context, it will be technically not random and it will technically not be a variable also. So you will see in a minute why it is referred to as such. So in probability context, the example which I give is, let's say you throw 2 dice. So all that what I am talking is written in the notes and I have uploaded on the drive before I came. I am not writing the verbose thing. I am just explaining it to you. Let's say I throw 2 dice, and of course you'll get one dice will have one number, the other dice will have another number. And sometimes I'm not actually interested in what exact numbers were there on the dice, but what was the sum of that. Make sense? Right? For example, you throw 1, 6. First one gets 1, the other one gets 6. The sum would be 7. But it could also be 6 and 1 and the sum will be 7. So I would sometimes only be interested in the sum. Two dice and not actual outcome. Interested. So the actual outcome, for example, if the sum is 7, let's say, what could be the actual outcomes? 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, one. There could be many outcomes. So instead of worrying about the outcomes, I only worry about the sum. Another example is, for example, you're filling the reservoirs in the tanks across the city, and the rainfall is coming. The civil engineer may not worry about how much the variation in the, for example, we have so many lakes around Indore, no, Pipilia Lake, Bada Bilawal, I don't know what. So they may not worry about what is the daily variation in the water levels in these lakes. What they will worry at the end of the rainy season, end of September, what is the level, for example. It could be that one lakes get more, it gets utilized more, but other one gets less water but utilized gets more. It could vary. So those variations we want to avoid. So another example is civil engineer not concerned with daily rise or decline of water level, but at end of season. So the quantities which are determined at the end of the result are referred to as random variables. So this sum, for example, is a random variable. The quantities at the total level at the end of the season is a random variable. So let me write the definition first, formal. I'll motivate you why it is referred to as what it is. Okay, so there's space here. Let's write a definition. So the definition says, given an experiment with sample space S, random variable is a function from S to real numbers. When I do the example, it will start getting more and more clearer. So you're doing an experiment on a sample space S. Random variable is actually a function. So that's why I'm saying it's not even a variable, from S to a real number R, which means, so are you saying something? So let's say this is my S1 outcome, this is my S2 outcome, this is my S3 outcome, and then I apply some transformation and I got to the real line. So outcome which maps this guy to, let's say, 0, this guy to 1, this guy to, let's say, 3. So this mapping going from an outcome, these are all outcomes inside the sample space. This mapping going from the outcomes to the real number line is referred to as the random variable. Okay. So what is important is why it is called random variable now. So you can also actually write it this way if you want. Let me just write it. Random because there is a random experiment. The mapping is deterministic. Once we start doing the example, it will be more clear to you. So you map certain outcomes to the real line, which you will see, like we're throwing dice, so we'll map 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1 to number 7. So that mapping is the random variable. So the experiment which you are doing, so the mapping is already there, that this maps to this maps to this. But to decide now, once you have done the mapping, let's say you throw the dice again and you get number 3. Well, 3 you will not get because there are 2 dice. Let's say you get number 8. So then now you want to see what was the outcome. So the experiment which you did, throwing the dice itself was a random experiment. So that's why the name random. The mapping is deterministic. 8 will come from 4, 4 or 5, 3 or 3, 5. That we already know. But because 8 came out randomly, it's called the random experiment. Make sense? We'll do more examples, it will be clear. So the above figure, you can actually write it with these numbers inside this also. If it is S1 outcome, S2 outcome, S3 outcome, we'll say this is 1, this is 2, this is 3. Sorry. This is 0, this is 1, this is 3. Alright. Let's move on to the examples. So we're saying let X denote the random variable that is defined as sum of two dice. Then you have to find the probabilities of all combinations. Let's say I'm not written then. You throw two dice, the example which I have given, and you have to find the probability of each outcome. So the first outcome which you would look at, well, you throw two dice, you can get number 2 or 3. I don't know what I was talking there. So let's say the outcome comes out to be 1, 1. Let's say this is my outcome. So what we'll do is we'll sum them up and we'll say X, which does the mapping from 1, 1 to equal to 2. This is the mapping. It is taking the event or the outcome and doing. Let's say now you get the sum 3. So you can get it from 1, 2 on 3, 1. Let's say. Sorry. 2, 1. So X of 1, 2, 2, 1 now will refer to this as 3. Yes? So if I have to write the probability of this, let's say if I have to write, probability of this, what will that be? This is possible in only once. How many outcomes we have? 36. Remember we made the matrix 6 cross 6. So 1 over 36. So instead of writing like this, we rather just write probability of X is equal to 2 is 1 over 36. This is 1, this is 2, and this way you can have more things. Why are we doing this will be clear more when we write more probability. So now let's say I have this 1, 2, 2, 1. So this I would write as probability of X is equal to 3, and that would be how much? 2 by 36, right? I'm already giving the number of total outcomes in the event I'm already giving you. So you just have to count them. Similarly, you'll keep doing, let's say it was 7. So then what will you write? You write 1, 6, 5, sorry. What did we write there? 3, 2, 5, all the way, let's say whatever, 6, 1. And this will be probability of X is equal to 7 is equal to 6 by 36. So you can say this is a cumbersome notation to write, because I'm not worried about what was the immediate inside the dices what they were throwing. I was only worried about the sum. For example, you're playing a game of Ludo with 2 dice, no? You would not worry about whether you got 2, 6 or 6, 2. You would just add the sum and say I got 8, so I'm going to move the 8 steps my, whatever you're playing with. So this is cumbersome. To make your work easier and not worrying about the details, we introduce the random variable. Is everybody okay? The intuition behind random variable? Okay. So this was the first example. We'll do multiple examples. Example 1A, 1B. Now let's say we were only throwing one dice. So the random variable is value of the first die. Only you're throwing, well, you're saying 2 dice, but you're only interested in the value of one die. So, and you denote that random variable by y. So what I would write P of y is equal to I is equal to 1 over 6, I going from 1 to 6. Because you're checking the value of the first dice. Let's do a more interesting example. Example 2. I think this we have done probably in class sometime. So the question, if I read it, I'll read it rather than write if that's okay to you. Suppose that an individual purchases 2 electronic components and each of them may be either defective or acceptable. So you have 4 possibilities. I think we did it somewhere. I don't remember where we did, maybe conditional probability. You have an acceptable and both are defective, defective, acceptable, acceptable, defective, and acceptable, acceptable. So you have a set of electronic components and each of them may be defective or acceptable, and you are want to pick 2 such elements. And the probabilities that both may be defective is 0.09, probability that this one is 0.21, this is same as 0.21, the probability that both are acceptable turn out to be 49. So now I define the random variable for you and you have to tell me the probability of that random variable, right? So let x denote the number of acceptable components obtained in purchase. So what values can x take? What is x? X is the sum of the outcomes, right? So x is the number of acceptable components to. So if you get both defective, then x would be. If you get this outcome, x would be. If you get this outcome, x would be again 1. If you do this outcome, the x would be 2. So what can x take? X can take values 0, 1 or 2. Everybody agrees? So the solution goes that x can take. Remember, we are doing mapping to the real number line. These were my outcomes and I'm mapping them. Now I'm going to write this mapping more explicitly and find the probability. Correct? So if I have to write the probability of x equal to 0, if this became really, this, you make it slant, it becomes darker. Maybe better for you. So I would usually not write this, but for the sake of, this is the probability of both being defective. Correct? Yes or no? What is the probability of both being defective? 0.09. then I would usually not write it. I am telling you for sake of explaining you. Otherwise, it's defeating the purpose of defining a random variable. Random variable is reducing your work and not worry about the inside of it. Probability of x is equal to 1 is probability of b comma a or a comma d. Everybody agrees with me? Yes or no? Now what can I do with this? Why would I add it? Because the two events are mutually exclusive. Either you will get this, all are mutually exclusive. It's not that you can get two together events. So the axiom number 3 says that it will be the sum of the two probabilities. I will not write this every time because you will do this in your head. P of a comma d and minus PA intersection d would be 0. So this is 0.21 plus 0.21, which is equal to 0.42. Yes? And the last one now is obvious. P of x is equal to 2 is probability of both are accepted, which is given to you as 0.42. Everybody comfortable what random variable is? So ideally I will not do all this work. You'll just do it in your head and then write it down. That is the probabilities which we are after. Sometimes rather than working with the x is equal to 0, 1, 2, you work with something called as an indicator function. Indicator function is a function which takes binary values. Either something exists or not. The name says itself indicator, right? So we define an indicator function. So sometimes only concerned that at least one acceptable component so define an indicator random variable. Our random variable is usually written as r dot v, and r and v are both small. In abbreviation we write it that way. We'll say it is equal to 1 if x is equal to 1 or 2, and it is equal to 0 if x is equal to 0. Because I just need to be worried about that, did I pick one, at least one acceptable of the two which I bought. Now if I have to find the probability of this, hey, you keep a track of time. I'm not wearing a watch. Tell me when 10 minutes are remaining so that I know where I am. So if I have to write P of, well, I is equal to 1, so that would be what? P is equal to x is equal to 1 or x is equal to 2. This is usually you not write, you can write union of x is equal to 2 or something like this because you're defining the event there. So that would be Px equal to 1 plus P of x is equal to 2. Again, they are mutually exclusive. It cannot be that you get both acceptable and one acceptable and one defective together. So again from axiom, so this is how much? This plus this, just 0.91. And then probability of I is equal to 0 is P of x equal to 0, which is 0.09. Everybody okay? Okay. So what we'll start is now, we'll start something called as a distribution. You say, what is distribution? You hear this quite often in Gaussian distribution, Bernoulli distribution, binomial distribution, all kinds of distribution. So distribution does it? It just tells how he's sleeping. Tell a joke. Hey, why are you sleeping at 11? Didn't sleep well? What's your name? Huh? Uday, Uday. Let's wake Uday up, find a joke. So what distribution does is it tells the spread of the random variables, which means that, for example, we are finding the spread of the probability of the random variable. Remember, we are writing px is equal to 1 or px equal to 0 or px equal to 2. That are independent values of the probabilities, which are, they are getting masked at one place. Px equal to 0 is 1, 0 is 0, this is 1, this is 2. So this is something which is referred to as the probability mass function, which I'll define when I talk about discrete random variables. But when you are interested for a range of these values for a random variable, for example, what is the probability when x is less than equal to 2? Then less than equal to 2 and you only have 3 values. It's a discrete variable. Let's say you have only 0, 1 and 2, and you're saying what is the probability x less than equal to 2. So you're looking at a range of probabilities, right? You will be looking at all the 3 probabilities which I mentioned, 0.09, 0.42, 0.49. So its distribution of the probabilities for a range of random variables is referred to as a distribution. That's the name where it is coming from. Okay? If you found the joke, then tell me. So, introduction, a distribution function or a cumulative distribution function or CDF. This probabilistic people, probabilistic or this probabilists or statistician, they really like these abbreviations. So now they call this as a cumulative distribution function as CDF. Describes how the probabilities are spread across a range of random variables. Okay, so that is how it is defined, how the probability is spread across for a range of random variables. So the definition goes like this. The CDF, we call it another function f of random variable x is defined for a real number x by, can somebody tell me how I'll define based on what I've written? I've written this already, the intuition behind it. So if I have to mathematically write it, how will I write? It's saying distribution of function or series, how the probabilities are spread across for a range of random variables. So the random variable is given to you as x, capital X, and its range is bounded by, let's say, small x, the real number. So the range would be, I'm not bounding it to 0, it can be any real number, right? Remember, it can map to the real line. I'm not saying to the positive real line. This probability is called your distribution function. Sometimes you write capital X also here to define that this is the distribution for capital X random variable. But the distribution is coming from the range of the random variable. Recall, for example, in the previous example, we could write this as p less than equal to 2, which would be p of x0, p of x1, p of x2. It's a different story, I'll tell you, they get added up, we'll all do all that later. But that is how the distribution of it will be defined, which will be f of 2. Yes? Now you do this for me to wake you up more. You see if there is a joke, otherwise. Did you send? Okay, I'll write the problem. You try to solve it and I'll read the joke then. Examples. So you are asked to compute P of A comma X less than equal to B given FB and FA. So in this problem, what is given to you? You're given the distribution at B value and the cumulative distribution function CDF at B and CDF at A, and you have to find this probability. How will you find it? Right. Can everybody see what Arunav said? Why? Let's write it down. So X less than equal to B is a union of everybody agrees that X less than B is a union of this. The A doesn't matter if you combine this, it will go to minus infinity. So now what we'll do, we'll just write this, the probability of this. So the probability of X less than B is equal to probability of these two together. These two are, please write this when you say, just don't write FB minus FA in the exam. For example, if you get something, write the steps that they have a union of this and these two are mutually exclusive. So I could have written a sum of them. So you write this and this will be P of X less than A plus P of A less than X less than equal to B. Yes? What is this? This is FB by definition. What is this? It's FA by definition, and you've got this guy. So which means this guy is FB minus FA, what Arunav just said. Everybody okay? That is how the distribution is. Okay, let's do the joke. So let me just write this. So P of A less than X is less than equal to B is equal to FB minus F. And when you finish a problem, it's a good idea to tell that you finished it in your answer sheet. So although we'll show you a quiz very soon, so that you know I don't deduct marks for it, but it's a good idea to tell that you finished something and not working somewhere else. Okay, example 2. Before I do example 2, let's wake Uday. He's already up now. English mein? Okay. A crowd of people gathered around the boy who swallowed a 10-cent coin. Nobody knew what to do. Then a man came out of the crowd, grabbed the boy by the legs and started shaking him. The coin fell out. People asked him, "Are you a doctor?" The man replied, "No, I am a collector." Okay. English jokes are not that funny, very frankly. Hindi jokes are more funnier. Or you know your native language jokes. Husband, the doctor said he would have me on my feet in 2 weeks. Wife, and he did. Husband, yes, I had to sell the car to pay. Not funny at all. I'm sorry. Okay. So you're given a random variable X with distribution, or I would say CDF f of x 0 1 minus exponential to the minus x square for x less than 0 and x greater than 0. So what is the probability that x exceeds 1? This is straightforward, but still do it. Don't tell the answer so that those people who have not understood can at least do it. So, do it now. Done it? Those who have done it, what's the answer? Of x greater than 1 would be, you take the axiom now. What was that axiom number 2? That is sum of this plus the proposition which I said, the complement is 1 minus that. So just 1 minus this string. Are you doing guys? What's the answer? So how would you write this? What's the answer? Why? One will cancel out. Well, capital X in this one is a real line, so you have to worry. It's very easy. Small x belonging to capital X. Capital X is belonging to the real line. Do it now. What did it mean? Write it at least. Think with me. If you're coming to class, make use of it. Right now? How will you write? Px greater than 1 would be 1 minus px less equal to minus 1, right? Remember the proposition which we told? The complement of something is, and you already given x less than equal to. This is for x greater. So you need to compute that probability exceeds 1. Okay? Marker. E marker. And power minus 1 because x is 1. ठीक है. I think with me now when the problems are not that hard. So what do we need? We need probability of x greater than 1, which we know is probability of. How do we know this? From the axioms, we had the proposition that the complement of the event is 1. Probability of an event is 1 minus probability of the complement of the event. Because the probability of the sample space is 1 and an event and its complement span all of the sample space. Correct? Everybody remember it now? So now we know this is 1 minus for x less than equal to 1. This is this guy, right? So this is 1 minus exp to the power minus 1. So this is e to the minus 1 or 1 over. A note which you should remember if you end up reading other books and other materials is that some people don't write this as a curly braces, they write it as a normal braces, normal. But the book which we are following and we are consistently going to do in all of the probability, whenever a random variable starts playing a role inside a probability, we make curly braces. It's just a notational thing to separate it from an event based thing. That when you're writing event outcomes, you usually write normal braces E, B, A, C. But when you put a random variable, although this is also signifying an event, because x greater than 1 is signifying some event, but we write it as a curly braces. Everybody okay? All right. So what we start now is types of random variables. I'll just briefly start, although I'll not be able to finish, so you'll have to come back at 4:45. Sorry? 10 minutes are there, but I'll just introduce. You don't have to write, you know. So types of random variables. So yesterday I'll just verbally tell you first. We'll write it formally in the next class. So when the range of the your random variable is a discrete set, whether it's a finite discrete set or it's infinite but countable, then it's called a discrete random. Okay, in principle. And when the range is a continuum, then it's a continuous random variable. We'll write it more precisely. But I said two things in the discrete. I said it's finite, that's okay. Like you saw 0, 1, 2. This was all discrete random variables because they were taking the range or the image of the random variable was only 0, 1, 2. But if it is infinite and countable, so now the question is, what is countable set? So I was asking Aruna, have you studied countability? Probably not. In which class? Actually, you started there. Okay, good. Have you studied? What is a countable set? Can represent it. What is a sequence? Sorry? Right, that's the answer. What's your name? Huh? So the correct answer for a countable set is, I'll write it down more formally, those who have not gotten it in the discrete math, that they should be a one-to-one mapping. One-to-one means one-to-one and a on-to mapping from these your numbers to the set of natural numbers. That set is called a countable set. So natural numbers, of course, a set of natural numbers. Finite set is always countable. There's nothing to worry because you can map with natural numbers. We are only worried about infinite set. When you go to infinite set, let's say you've got the set of rational numbers. What are rational? Which are represented by the ratio of two integers, right? That's a rational number. So the question is, are the set of rational numbers countable? It is. It's not that straightforward. You'll have to prove it. Is the set of real numbers countable? Why is it not? For every decimal we can find. So there is a whole involved proof in it, which is covered in an advanced calculus or a real analysis class. So we'll not worry about it for you because that's out of scope for you. But the definition of a discrete random variable says the range can be finite. The simpler books which are written for engineers or statistics will say, okay, take finite ones as discrete, take infinite ones as continuous. But that's not the case. If it's infinite and countable, let's say the set of rational numbers, then that will fall under a discrete random variable rather than a continuous random variable. So what I'll do, I'll briefly write countable, write the definitions and then go from there. When you have a discrete random variable, the probability function, which all of them which we were writing until now, we were working with discrete mostly, except this example where it became continuous. The probability function is called the probability mass function. And the name mass, as I said, came from that you have probability 0, probability at 1, probability equal to 2. These are massing at different paces. So that's why the word mass. When you have the continuous, it's referred to as the probability density function. So there is a name density involved in it, which we'll see. Okay, so that is about that. Before you go, there's the 5-6 minute. I'll just write something which I wanted to tell you. That day I didn't bring your feedback. So we still have 4 or 5 interactions left. So this is something which okay. So okay was okay, page structure upload. Now you're comfortable with my lectures. Practice problems, were they useful before the quiz? Okay. PAs, there were 3 comments. The handwriting is not good. Not readable at the back. Questions, discussion should be done in more detailed way. And they should be given time to solve. So how was yesterday's tutorial? Did it cover all these things? Yesterday, sorry, today's tutorial this morning. Was it better? Okay. Then the question was relate to ML. So this, what we'll do is, today in the second half we'll have the lecture number 11. Then Monday you will have the tutorial for this part, the random variable and types of random variable. Tuesday I'll do statistical part of probability, which is expectation, variance, covariance. And then Wednesday we'll finish it with the topic on ML. So I'll tell you regression where gradients play a role, support vector machine where certain vector calculus come. I'll tell you the naive Bayes classifier where the probabilities play a role. So I'll give you an overview. So that will give you an idea where this is used, but that will not come in the exam. Exam will be only till Tuesday. There were smaller minor comments. Why extra class not needed? Well, extra class are only being done because we are missing lectures here and there. I am not usually doing board wide, that is done. Notice more people. I don't know how to do that. I come to you. You guys are not working at the back. I don't know. Do something, no? Don't write my notes, but at least solve the problems. Like these guys are doing in their head, no? At least do it in the head and tell me that you've done it, so that I know you're getting it. Videos we have released already. There was a comment on do one topic at a time. These topics are very small and they are not detailed, so I'll have to cover multiple topics. We have less time, so there's no choice on it. Hai na? So we've addressed all your feedback. Okay, so see you at 4:45. Hai na? We'll finish by 5:30. I'll not keep you long.